It says, what is the sum? Right away, when I see the word sum, I know it's a series formula of some kind. This one says of a geometric series. There's the hint. It's a geometric series formula, so I write the geometric series formula. Sn equals A1 minus A1 times R to the n over 1 minus R. When I continue reading this, it says it has 8 terms. If it has 8 terms, what letter would that be? Yeah. What is the number of terms? It's just n. If there are 8 terms, that means that n is 8. It says whose first term is 3, what would that be? A1 is 3. And the common ratio would be the letter R. It says R is 4, which means it follows the times 4 pattern. If I look in my formula, I needed A1, I have it. I need R, I have it. I need N, I have it. It gave me everything I need. There's nothing missing. If there's nothing missing, I can take all those pieces and I can plug them in. So S sub n, which is 8, equals my first term, which is 3, minus my first term again, which is 3, times R, which is 4, all raised to the n, which is 8, over 1 minus 4. Same rules apply that we had yesterday. You have to plug in the top first, press enter, then divide by one number. So you want to simplify this. That'll be a negative 3. I'm going to divide by negative 3, and then press enter. If you have the 84 calculator, you can alpha y equals enter instead and plug it all in at once. So I repeat, if you have the 84, you can press alpha y equals enter and plug it all in at once. Entirely up to you how you would like to plug it in.
So alpha y equals?
Alpha y equals enter. This is what you should get. Now, we're going to be plugging it in a bunch today, so if you didn't get that, please let me know now and I can help you so we can get all the rest of them. And that would have made it a positive. So you're right there. You should have done 3. Somebody else not get 65535. Okay.
What do you mean by plugging that in? Like I plugged that in and it didn't pop up. You said alpha y?
Alpha y equals is the top left button. Enter.
And then it pops up n over the
enter.
But it pops up all in correction.
Yeah, you have to fill it in. The little blank spaces?
Oh.
There. Yeah. Like it's very.
They meant after.
No, yeah, that's why it wasn't working. Isn't that working?
Okay.
Did you already press enter and do more? Okay, hit second enter. You divided by -4. So that was it. If you don't get it again, let me know. I smelled cheesecake just now.
Yeah, I'm not making it up.
I thought you were a little crazy, but. Exercise 2. Big important. Super fun. My favorite example is the notes. It says in the directions, what is the sum of the geometric sequence? When you see sum and it's saying geometric, you have to use your geometric series formula. So I'm going to start by writing it. Sn equals A1 minus A1 R to the n over 1 minus R. So I look in the formula at what I need. It says I need A1. A1 is what for this one? 4. It's the first term in my sequence right here. R is what I multiply each term by to get to the next one. To get from 24 to 48, what am I multiplying by? 2. So if I'm multiplying by 2, that means that R is 2. What's the only other letter I need in this formula?
A of n.
Mm.
Or, oh, sorry, n.
Good, N. Just N. There is no A of N in this
Yeah,
case.
find it.
So if I don't know what N is, I would have to find that separately. You can't figure it out based on the sequence because N is the number of terms. And there's this dot, dot, dot here. There could be 100 terms in there. There could be 2 terms in there. I have no idea, so I have to find it. So off to the side, I'm gonna have to find N. So just like we talked about yesterday, if you're missing a piece of information, you have to jump back to the sequence formula to find it. Specifically for this one, the geometric sequence formula. So if AN equals A1 times R to the N minus 1. If I'm finding N, that's the only thing I'm not going to plug in for. So I have to plug in for AN, A1, and R. A1 I already stated was 24. R is what I'm multiplying by each time, which is 2. I'm going to leave N as N, because again, that's what I'm trying to find. And what does AN represent?
1,500.
There you go. Which is my what? What term?
Last term.
Last term. AN means last term, so I go up to my sequence. This is my last term, so that's AN. And I'm going to plug that in for AN right here. So 1, 5, 3, 6.
Well,
How do you know?
Does it look like one?
Anytime you have a variable in the exponent, you have to use logs. Woohoo! But I can't use logs yet.
That'd be fun.
Logs are fun. Do you want to play a song?
No.
We're
Yes,
okay.
Please.
Why
Don't-
Maybe after class. Maybe
Maybe-
after class.
Maybe. We need to focus on work now.
That's right. You're right. You're right. We need to focus. I'm sorry that I got us off track.
Divide by 24.
I have to get what's being raised to the variable by itself first. This is the only part that's being raised to the n. So I can't take the log of both sides until I divide by 24 on both sides.
And you take the log of what that is and 2.
Alright, Jamie,
And
want
then
to
you
do
do
class?
n plus 1. So you arrive at n. And then you gotta plug it into s of n.
Logs
Thank
are
you very
very
much. Logs are bang. 1536 divided by 24 is 64. So I get that 64 is equal to 2 to the n minus 1. Now it's ready to take the log of both sides. Now what's really, really nice about using logs in this chapter is I'm only ever going to use logs to solve for n. And n represents the number of terms. Am I ever going to get an icky decimal? No, I can't have 4.5 terms. It's always going to be a nice, solid number, which is wonderful. So this one's going to be the log of 64. Where does n minus 1 go when I use logs?
Front.
The front. Remember when we hated logs? Look at how good we are now. As soon as you use the log to bring that exponent to the front, you're done using it now, so you have to get rid of the log of 2 by dividing both sides by the log of 2, which will get you a nice number. Did anyone already plug it in? The final answer, 7. When you divide the log of 64 by the log of 2, you get 6, which equals n minus 1. So my last step to solve for n would be to add 1 to both sides. What does n equals 7 mean? There's 7 terms. Which is great. It's good to understand what's going on. But again, this is just a formula. So I'm going to go up here and say that n is 7 and plug all of it in just like I did for number 1. So s little 7 equals 24 minus 24 times 2 to the 7 over 1 minus 2. Please make sure that you are practicing plugging this into the calculator. You do not want the first time you plug this into the calculator to be when you're taking the test. It happened a little bit in the log chapter. Some people didn't know how to plug some stuff in. You've got to practice it during class so you're not like, the second it comes to the test.
Did you get a test back?
When everyone takes it.
Which feels like it, yeah.
No, I feel like it.
How much did I got
What do you got?
one?
All right, number 3 also does not give me all of the information. But when I read it carefully, Find the sum of a geometric series. Those are my keywords that tell me I have to use this formula. We're on the back page. Try and see if you know it. I know it doesn't need to be memorized. Try to write it up, see if you've got it already. After you write it a couple of times, usually it's like, oh, got it. So again, same formula. I need A1, I need R, I need N. So off to the side, I'm going to write that out. I need A1, I need R, I need N. Couple pieces were given in the directions. A1 is 19. It says it consists of 5 terms. What letter would that be? N.
We don't got R.
We don't have R. We don't got R.
R.
So I need to find R down here. Finder. Now I don't find R using the series formula, right? Right.
Right.
I go back to the sequence formula. This guy. No logs for this one though, because I have N. So A1 was 19. R is what I'm trying to find. 5 minus 1 comes here. That means I'd have to plug in the last term. Do I know the last term?
Yes, you do.
Yes, you do it, it's 304.
Wasn't that so kind that it told me? A sub 5 is 304. If N is 5, these match up. So that means my 5th term, or my last term, is 304. So that's going to go right here. 304. Now myself, just like I did with logs, even though I'm not using logs, I still have to divide by that 19 to start. So 304 divided by 19 is 16. And that's just going to equal R to the 4th. 5 minus 1 is 4.
You gotta do the thing.
You gotta do the thingy. What's the opposite of 4, like raising something to the 4th?
Quadruple rooted.
Quadruple rooted. You have to take the 4th root of both sides. This 4 and this 4 will cancel each other out. Now, I know some of us have been still having a hard time plugging this in, so I'm going to show you how to plug it in. You have to hit the number of the root you're trying to take first. If it was the 5th root, 6th root, 7th root, you have to hit the number first. So this is the 4th root, I'm going to hit 4. Then you go to math. You'll notice they have the cubed root already preset for you, but that's not what we're looking for. We're looking for the xth root. That will be any other root you're trying to take. I need twist 5. Some of your calculators will look like this. Some of them I'll just have the 4 out in front. It doesn't matter. Either way, it's plugging that 4 in there, and then I have to type in 16. So the 4th root of 16 is 2. Isn't that a nice number? So R is 2. What does that answer mean?
It
How much
changes
multiply
times
by?
2. Yeah.
I'll show you in a second. It's what you multiply by each time to get to that. So R is 2. I now have all of the information I need. Take a second to plug it into that formula. I'm going to throw the answer up here.
This is so much better because it's like actual, you know when you're wrong. Because you don't get it
You don't want to do it twice. Why did you write? It should be 5. I don't know why I wrote 8. Good question. I have no idea. I don't know. Did you guys get 589? Or did I copy the wrong answer?
No, I don't know.
Okay, so let's just ask for 5.
What happens if they're-
Yeah.
It was so stupid.
I missed it there somewhere.
It was so pointless.
What was this thing for? Don't arrest.
No, it's like,
Don't attempt.
Yeah.
That's not how you
Oh,
spell
I
that.
did not. I was fine.
what was it?
One minus
Don't. 10.
Anyone else? Did we get 589? Okay, two more. Exercise 4 says, again, find the sum of the first 5 terms. If I'm finding the sum, I'm going to use this formula. This one's tricky.
Why can't they just say?
It's honestly not like too much tricky. So it does give you all the information, it's just hidden. I can clearly see what the first term is. It says A1 is 3. That one, very obvious. I also know that I need R and I need N. In the directions, it says find the sum of the first 5 terms. What letter would that be? N. That's how many terms there are. R is the thing that's tricky to find. It gave me a recursive function. Recursive functions is that thing we did on day 2, where there's 2 parts to the function. It always gives you a start and then the pattern. What does this piece mean? Very good. That means the previous term. That's what it means to be a recursive function. It takes the previous term and it applies the pattern to get to the next term. Huh?
What are we two?
Or would be 2. It's telling me to take the previous term and multiply it by 2. Then I find the next term. I take that term, multiply it by 2. The pattern here is times 2, which means R is 2.
Well, we still have to plug it in for A and then.
You still have, what? What'd you say? Are you on saying it? Okay. So I have everything I need. It was hidden in there that the 2 was the multiplier, but if you remember that previous term thing and the pattern was recursive functions, not too bad. And these need to get plugged in now. So this is S of 5 equals my first term, which is 3 minus 3, 2 to the 5 over 1 minus 2. You should get 93. You want to point something out in the formula because it kind of tricks people up sometimes on the homework. When you're writing this out, it's really tempting to say that 3 minus 3 is nothing. That's not the case. You can't do subtraction before you do this multiplication. You can't do that multiplication before you do the exponent. Your calculator knows how to PEMDAS that, so always just type it straight in. Don't try and do it piece by piece. Number 5. The weird example. So a person places 1 penny in a piggy bank on the first day of January, 2 pennies on the second day, 4 pennies on the third, and so on. What's he doing each time he puts the money in? Multiplying by 2. It was 1 penny the first time, then 2 pennies, then 4 pennies. The next one would be 8 pennies, and so on. Like it says. Will this person be a millionaire by the end of January? Probably not.
Probably not.
Probably not. He's just putting pennies in this piggy bank. But we have to answer the question, so we have to figure it out. The amount of money that's going to be in the piggy bank in total is a sum of all of the things that he put in there. So this one is kind of like coded in there. It's not specifically saying sum, but it wants to know the total amount of money in there by the end of January, which means I have to add this, plus that, plus that, plus all of the terms. So this is that same formula once again.
Type in that, like,
Yeah. Is that okay?
That might be-
Now my sequence on the first day started with 1 penny. On the second day, which means it's the second term, it was 2 pennies. On the third day, it was 4 pennies. And so on. You don't have to write out the sequence, but I highly recommend you guys, if you have a word problem, write it out as a sequence. It makes the other pieces kind of fall into place a little bit better. So these are the things I need. I know my first term is 1 penny, so it's 0.01. R is what I multiply by to get from one term to the next, so what would R be? 2. I'm multiplying by 2. 1 penny, 2 penny, 4 penny, and so on. N is the number of terms I have. So on the first day of January, he puts in his first little deposit into his piggy bank.
31.
Very good. Wants to know how much is in there at the end of January, and there are 31 days in January. So that means that N is 31. This isn't super relevant to the question, but my last class asked, and I think you guys might like to know this as well. If something like that came up on the Regents exam, and you're sitting there and you're like, I have no idea how many days are in January, that's something you're allowed to ask us, and we can tell you. Like if you don't know how many weeks are in a year or how many days are in a year, and you need to know something weird like that that's not really like taught in the course, it's supposed to be common sense, and you just don't know it because sometimes you don't know, like how many letters are in the alphabet. You might need to know that for a question, and if you don't know it, we can come over and say it. 26.
February is random every year.
What?
Throw on February, right?
No,
It's not random every year.
They
They probably wouldn't do February because it could depend on the year.
on a leap year.
Anyway, I have all this information. Let's find out if this dude's a millionaire. So S sub 31 equals, my first term was 0.01 minus 0.01 times 2 to the 31st over 1 minus 2.
There's like 27 there, you know, yeah.
When you plug this into your calculator, this is the answer that you get. Obviously, this is a giant, giant piggy bank. But what this example is supposed to kind of represent to you guys is that geometric sequences can grow really stinking fast. Like, yeah, we started with a penny and 2 pennies and 4 pennies, but eventually you're going to get to $1 and then $2, which is $4, $8, $16. Watch how fast it instantly starts growing. 32, 64, over 100. And we're not even halfway through the month yet. So eventually those numbers get really, really big, and if you add them all together, it's going to be super big. Specifically, 21 million big. Very, we're not doing the last one. It's a terrible example. If you want to rip it out of your packet and make it a little bit smaller, go for it.